Hello everyone. So glad to be back on doing another video. I'm right, this is class number 6 today. So we are doing class number 6 today. So there are some topics I want to cover. Matrix operations. Earlier, the last video we did matrices, vectors, and what else? NumPy arrays. Today is a continuation to that one, matrix operations. And everything is related to that. Numerical linear algebra, some introduction to numerical linear algebra. Solving polynomial function. And most importantly, plotting graphs, plotting 2D graphs. 2D graphs. All right, let's begin with matrix operations. So last week we learned how to write or define a matrix on Python. So let's apply some methods on that. So this one, first we'll look at how to get the transpose of a matrix. Transpose. All right. So let me write it. First, let me define the matrix, define some matrix np.array. One, two, three, four, 1, 2, 3, 4. Print a. We know what is going to print here. Okay. Oh, I couldn't import the NumPy module. Import NumPy as np. Now this should work. Okay. The first row is 1, 2. The second row entries are 3, 4. That's fine. Now let's get the transpose of the matrix. Now, first, do you remember what's transpose is? Now we have. Now I should have done linear algebra first, but let me briefly tell you what the transpose is A equals 1, 2, 3, 4. And we know that these are rows. These are rows. This is the first row. This is the second row. This is the first column. This is the second column. We define a transpose as the rows become columns. First row becomes the first columns. 1, 2. Second row, 3, 4. Second row becomes the second column. Now you will notice that this row has become a column and this row has become the second column. Similarly, the first column, 1, 3, the first column has become the first row. And you also note that the second column has become the second row. So in the transpose operation, rows become columns, columns become rows. So that is what happens. So when we get the transpose from Python, we should ultimately end up with this one, end up with this matrix as the transpose of A. Okay. Then transpose, how we get A dot transpose. Transpose of A. We are getting 1, 3, 2, 4. This matrix. That's fine. Next one. Element-wise functions or operations between element-wise functions or operations. You will see what it means. Technical element-wise operations. Okay. I call my A matrix A equals np dot array the next 1, 2, 3, 4. B equals np dot array equals np dot array 5, 6, 7, 8, 5, 6, 7, 8. Okay. Print A. Print A. Okay, that's fine. Print B. Five, 6, 7, 8. That's fine. So addition. We know how to add matrices of similar or the same order. Addition. Print np dot add. Add is the function here. Np dot add A comma B. So let me write something for you. Okay. In the matrix addition, we know that what? 1, 2, 3, 4. This is the matrix A plus 5, 6, 7, 8. 5, 6, 7, 8. B. So when we are adding two matrices for what we are getting, we are adding corresponding entries. So 1, 1 place. This is the first row, first column place. Heads up with first row, first column place. So 1 plus 5 is 6. First row, second column place. 1, 2 place. Adds up with the 1, 2 place of the next matrix, B. 6. Let me write. 1 plus 5 here. 2 plus 6. 2 plus 6 here. 3 plus 7. 3 plus 7 here. 4 plus 8. 4 plus 8. 1 plus 5 is 6. 2 plus 6 is 8. 3 plus 7 is 10. 4 plus 8 is 12. So this should be the matrix we are getting from this add function. We'll see if we are getting that. 6, 8, 10, 12. Correct. Oh, I have to admit my 6 looks bad here. Okay. 6, 8, 10, 12. That's fine. Let's move on to the next one. Print NP subtract AB. Print subtraction. Okay, subtraction. Can you remember subtraction from your, I think this matrices addition and subtraction is done in your O-level C1. Surely in the A-levels, I don't know if it is done in the O-level exam. We'll see. Subtraction. I'm subtracting 1, 2, 3, 4. This is the I am subtracting print NP subtract AB. NP dot subtract A comma B. We are trying to predict here what we are going to get. We are subtracting B from A. 5, 6, 7, 8. So subtract corresponding entries. 1 minus 5, 2 minus 6, 3 minus 7, 4 minus 8. 1 minus 5 is minus 4. 2 minus 6 is minus 4. 3 minus 7 is minus 4. 4 minus 8 is minus 4. Minus 4. Interesting. Isn't it? We got all minus 4. Yeah, that's how you subtract. So when we execute this one, when you run this code, we will get the correct one. Yes. So that is fine. The next one, multiply element wise. Okay. Multiply element wise. Print np dot multiply ab. Multiply a comma b. Okay. What's the A matrix? The A matrix is 1, 2, 3, 4. Multiply. The multiply function, multiply it looks ridiculous, right? This is the operation like addition, subtraction, multiplication. So I don't have a particular symbol for this, so I write multiply. Multiply element wise. Multiply element wise. Okay. A and B. 5, 6, 7, 8. 5, 6, 7, 8. So we multiply element wise. The first entry multiplied by the first entry here. 1 into 5. 2 into 6. 3 into 7. 4 into 8. 4 into 8. 5. 12. 21. 4 into 8. 32. 5, 12, 21, 32. Let's see if we are getting that from the multiply function in Python. NumPy. 5, 12, 21, 32. Correct. We are correct. Next is division. Division. Divide element wise. So we divide element wise. Print np dot divide a comma b. Divide. So the matrix is A matrix is 1, 2, 3, 4. The operation is divide element wise. B matrix is 5, 6, 7, 8. So divide the entries in A with the corresponding by the corresponding entry in B. For example, the first entry here, 1 is divided by 5. 1 is divided by 5. 2 is divided by 6. 3 is divided by 7. 4 is divided by 8. So 1 divided by 5. What is that? 0.2. 2 divided by 6. Which means 1 divided by 3. 0.333. It's a recurring decimal. 3 divided by 7. 0.428. 4 divided by 8. 1 divided by 2. 0.5. So basically we are getting 0.2, 0.33, 0.42, 0.5. something like that. So you should be getting that from this one. Yes, correct. Now we have to note here that in the earlier command, multiply, we multiplied element wise. We multiplied the corresponding elements in the matrices. But this is not the matrix multiplication. Matrix multiplication is something different. So let me clear this one. Matrix multiplication. It is np dot print np dot matmul. Matmul means matrix multiplication. Matmul. Matmul ab a comma b. Okay. Now can you remember the matrix multiplication? Let's recall. Now our first matrix A. What is A? 1, 2, 3, 4. 1, 2, 3. Oh. First matrix A is 1, 2, 3, 4. So we multiply by the B matrix. 5, 6, 7, 8. So how do we multiply two matrices with matrix multiplication? We multiply, okay, now, okay. We multiply the first row by the first column of the second matrix. First row of the first matrix by the first row of the second matrix to get the first entry here. So 1 multiplied by 5 plus 2 multiplied by 7. This is the first entry of the resulting matrix. The second entry, how do we get the second entry? And third entry and fourth entry. The second entry is obtained by multiplying the first row of the first matrix multiplied by, in fact, the dot product by the second row of the second matrix. 1 multiplied by 6 plus 2 multiplied by 8. 2 multiplied by 8. Okay, here, the second row, first column entry, the dot product between this one and this one. The second row of the first matrix, first column of the second matrix. 3 into 5 plus 4 into 7. The next entry, this row multiplied by this column. 3 into 6 plus 4 into 8. Here, 5 plus 14, 6 plus 16, 15 plus 28, 18 plus 32, 5 plus 14, 19. 6 plus 16, 22. 15 plus 28. 5 plus 8 is 13. 1, 2 plus 43. 8 plus 32. 8 plus 2 is 10. 1, 5. 19, 22, 43, 50. This is the resulting matrix resulting from the matrix multiplication between A and B. So we can see if we are getting that from the matmul function, matrix multiplication. 19, 22, 43, 50. Correct. It gives us the correct result. Okay. The next one. Okay, now our A matrix is, what do I call that? 1, 2, 3, 4. That's fine. We can get the square root of each element using the sqrt function in NumPy module. Print np dot sqrt8 sqrt8 sqrt8. So we are getting square root of each number like this. And we have the A matrix here. 1, 2, 3, 4. Square root of A is obtained by getting the square root of each entry. 1 square root, 2 square root of 1, square root of 2, square root of 3, square root of 4. Square root of 1 is 1, square root of 2 is 1.414, and so on. Square root of 3 is 1.732, and so something. Square root of 4, we know it's 2, 2.0 or 2, whatever. So we should be getting the same ones. 1, 1.41, 1.722, 2. So we'll see. Yes, we are getting that. Next, the log function. Print, sorry. Logarithms. Print np.log. np.log A. Okay. Let me just run this first and see what this is giving, because I'm not sure how Python calculates this. Okay. Now my A matrix is 1, 2, 3, 4. Now here I'm trying to understand what this log function is. Now it has given the log of 1 to be 0. Of course, 1 is the 0th logarithm, or the 0th index of any number, 0th power of any number. So the log of 1 is 0. So this is giving me log of 1 log. I'm trying to understand the base here. Um, log of 3 log of 4, which is fine. But I still don't know what the base is. Base comes here. Can you remember uh, let's say b, log of b to the base a. So we know b's, all b's, but we don't know this simple a's. So I'm trying to understand what the a is. Now log of 2 is, Python has given me 0.693 something. Okay. Log of 3 is 1 point something. Ah, so this definitely cannot be uh, the base of 10, because the log becomes 1 uh, when the base is 10. The log becomes 1 only when the index or the power becomes 1. Sorry, when the base is 10, the log becomes 1 only when the number becomes 10. So I think this is the natural logarithm. Log e. Okay. So yes, that's correct. Now it's correct. So this is the natural logarithm. All right. Okay. So yeah, that's fine. You can also check that. This log function calculates the natural logarithm of each element of A. Okay. Uh, Natural logarithm means logarithm to the base E. Okay, that's fine. Next one, dot product. Dot product. We take dot product between two vectors in mathematics. V equals np dot array, np dot array. V equals np dot array 1, 2, 4, 5. Let me say 1, 2, 4, 5. 1, 2, 4, 5. Let me define another vector w equals np dot array. Now let me define a column vector. Again 1, 2, 4, 5. 1, 2, 4, 5. Sorry. 2, 4, 5. Now my B vector is a row vector, which is 1, 2, 4, 5. I have 4 entries. The shape of this is 1 into 4. I have my W vector. which is a column vector. 1, 2, 4, 5. Okay, that's fine. Now I want to get the dot product between V and W. Print np dot dot function between v comma W. That's fine. Now what will we get? Do you remember the dot product? So we are multiplying 1, 2, 4, 5 vector over this matrix by 1, 2, 4, 5. So when we multiply this by this, so 1 into 1 plus 2 into 2 plus 4 into 4 plus 5 into 5. 5 multiplied by 5. This is 1 plus 4 plus 16 plus 25, which is 1 plus 4 is 5, 30, 40, 46. The answer is 46. The dot product between these two vectors comes down to 46. So let us see if we are getting 46. Yes, correct. Python gives the correct answer for the dot product. Next, cross product. Now, this is a good opportunity for you to actually know the mathematics behind every NumPy command instead of blindly executing commands. Cross product. Cross product. And let me define a vector np.array 1, 2, 3. P dot any vector 1, 2, 3, 1, 2, 3. Another vector y equals np.array, let me say 4, 5, 6. I have my two vectors x and y of the same shape. Okay, I made a mistake. What did I do? Module NumPy has array extra is here. Okay. We have defined my two vectors. Now I get the cross product between x and y. Print np dot cross product between x comma y, x and y. Now, what is this cross product? Can you remember? Let's try to do it manually and let's see if we are getting the same answer from NumPy module. Okay, now my x vector is 1, 2, 3. Y vector is 4, 5, 6. So I can also write this in the form of ijk. Now I have, this is a three-dimensional one. So it's 1 into I plus 2j plus 3k. ijk, can you remember? This I is the unit vector along x-axis. J is the unit vector along y-axis. K is the unit vector along z-axis from your A-level knowledge. 4i plus 5j plus 6k. How do you get the cross product between x cross product y? We write ijk here, ijk. Write the entries, write the coefficients of this matrix, this vector first. 1, 2, 3. 1, 2, 3. Next, the coefficients of the next vector y. 4, 5, 6. 4, 5, 6. Coefficient of I is 4, coefficient of j is 5, coefficient of k is 6. Okay. Next, you get the determinant of that. Okay. As I said earlier, I should have done linear algebra first, but I wanted to rush to the numerical analysis first because it's being used and it's useful for many of us who are doing research, and so most of us have already the experience, or most of us have already studied the linear algebra. So I assumed we have already studied, and so I wanted to rush to the numerical analysis. But if you have not studied, then don't worry. I'll try my best to explain everything here. Or else you can study linear algebra from me after doing numerical analysis and optimization and some other modules. Anyway, how to get the determinant of this? You get the first entry, I, and you get the determinant of this part. 2, 3, 5, 6. Minus. Alternatively, we write plus and minus. Here plus I, next minus j. We omit this row, the row containing j, and column containing j. We get the determinant of the rest. 1, 3, 4, 6. 1, 3, 4, 6. Alternatively, I told you, alternatively, we are writing plus and minus. Plus I minus j plus k. So we are omitting the row containing k and column containing k. The rest we get the determinant. 1, 2, 4, 5. 1, 2, 4, 5. Determinant of that. Now determinant of this is 2 multiplied by 6 minus 3 multiplied by 5 minus j 1 multiplied by 6 minus 3 multiplied by 4 plus k 1 multiplied by 5 minus 2 multiplied by 4. Okay, 2 into 6, 12 minus 15 minus j 6 minus 12 plus k 5 minus 8. Answer is 12 minus 15 minus 3i minus 3i. 6 minus 12 minus 6 multiplied by minus 1 plus 6j plus 6j 5 minus 8 minus 3 minus 8k. So the x cross y is minus 3i plus 6j minus 3k. So this should be minus 3 plus 6 Right, 3 plus 6 minus 3 in the matrix form. Okay. Or any, let's say, any multiplication of this. Let's see. Minus 3 plus 6 minus 3 plus 6 minus. Okay. Yes, correct. Oh, we are correct. So what does this mean actually? This physical meaning of this is, let's say we have a vector x and we have a vector y. The meaning of the cross product is cross product between x and y is we are getting a vector perpendicular to x and y. This is perpendicular to this, and this is perpendicular to this. So this is the x cross y. You understand? So, yeah. So I'll teach you them in detail when if I am doing linear, when I am doing linear algebra to you. Just for now, this is sufficient. This understanding is sufficient. Okay. Let me write here. A vector perpendicular to x and y. We are getting a vector perpendicular to x and y. So this is vector. Okay, that's how we get the cross product. Next is mean. Let me say my vector is v equals np dot array. Let me take my vector 1, 2, 4, 5, 2, 4, 5. It doesn't have to be, it doesn't necessarily have to be 1, 2, 4, 5. You can write any vector. Okay. Print v. Print v. Next, print mean v. Mean np dot mean v. np dot mean v. np dot mean v. What will I get here? I know that v equals 1, 2, 4, 5. Can I get the mean of this? Mean v. It is 1 plus 2 plus 4 plus 5. We add up all the entries and we divide it by the number of entries. 1, 2, 3, 4. 4 number of entries are here. We divide it by 4. 3 plus 4 is 7. 7 plus 5 is 12. 12 divided by 4 is 3. So we should be getting 3 as the mean. Okay. Oh, yes, we are getting three. So I have to actually raise my voice here because it's raining heavily outside. So the rain hitting the roof, the sound of rain hitting the roof, uh, it comes really loudly. So I'm not sure if I'm speaking loud enough to you. Okay. The next one. The mean is fine. A equal, let me write another example. Matrix np dot array 1 2 3 1 2 3 4 minus 5 6 4 minus 5 6 5 minus 6 7 5 minus 6. Okay, let matrix A be that one. Print A. It's just an example. You can write any matrix you want. Next, I actually wanted to see what happens when I write print np dot mean A. np dot mean A. One point A. So what does this mean? Yeah, it means that it similar to the vector example we did before, this one, similar to this one, what this does is it adds up all the entries in the matrix and divide it by the number of entries. So you can check it as a homework. So since it will take some time for me to manually calculate and show it to you, I'm not going to do it here. You can check it by using a calculator or something, a separate one. Okay, that's fine. The next one, print np.mean A, np.mean A, axis equals 0. This is the mean of row wise. Mean row wise. What does that mean? Let me run the code and see what happens. So it gives me a vector, 3 point or something. Okay. Let me write that one. So my matrix A is 1, 2, 3, 4, minus 5, 6, 5, minus 6, 7. This is my matrix A. That's fine. Now, what is this axis 0? Axis 0 is this one. This direction is axis 0. And this direction is axis 1. So when we are getting the mean along axis 0, we actually add up the columns, entries in the columns, and divide the number of entries in that column. So here, what we are getting is 1 plus 4 plus 5 divided by 3. Number of entries is 3. Here, 2 plus minus 5 plus minus 6 divided by 3. 3 plus 6 plus 7 divided by 3. So this is the vector I'm getting. 10 divided by 3. Minus 11 minus 9 divided by 3. 6, 7, 8, 9. 16 divided by 3. So here 3.333, here -3, here 5.333. Yeah, correct. Python is giving me the correct answer. Next, print np.mean, print np.mean, mean of A, axis equals 1, axis equals 1. Mean column noise for the so when the axis is 1, what happens? In this direction. In this direction. It is 1 plus 2 plus 1 plus 2 plus 3 divided by 3. 4 plus minus 5 plus 6 divided by 3. 5 plus minus 6 minus 6 plus 7 divided by 3, which is 3, 6, 3 plus 2 plus 1 is 6 divided by 3, 2. 6 plus 4, 10. 5 divided by 3 is 1.66, round up 7. 5 plus minus 6 plus 7. 6 divided by 3 is 2. 2, 1.667, 2. So this is the vector. So it gives me as a column vector 2, 1.667, 2. This is the answer. So it is what we are getting here. Correct. Okay, the next one, sum. How do we get the sum? Let's see, print A first. Revise what the A matrix is. Okay, this is the A matrix. Now, print, I want to see print np dot sum of A. Sum of A. So you can check, this gives the summation of all the entries. 1 plus 2 plus 3 plus 4 plus minus 5 plus 6 plus 5 minus 7 plus 7. You add them all up and you will get 17. Next one. Print np.sum, np.sum, summation of A. Axis equals 0. Okay. Now my A matrix is 1, 2, 3, 4 minus 5, 6, 5 minus 6, 7. Now, along axis 0, you can add things up. So when you add up the columns, you will get this one, right? For example, the first column 1 plus 4 plus 5. It is 10. Same with the second column, you will get -9. Third column, you will get 16. Next, print np.sum A axis equals 1. Along axis 1, you should be getting 6, 5, 6. You should be getting 6. 1 plus 2 plus 3 is 6. 4 plus minus 5 plus 6 is 5. The next one is 6. So Python gives me this as the row vector. Okay. The next one, product. Okay. Let me recall my A vector. Print A is fine. NP dot product A. Print NP dot product product function A. It takes some time. 151,200. So what does that mean? This gives the product of this gives the product by multiplying all the elements in the matrix. 1 multiplied by 2 multiplied by 3 multiplied by 4 multiplied by minus 5 multiplied by 6 multiplied by 5 multiplied by minus 6 multiplied by 7. So it gives me a positive number because I have two negative numbers. When they are multiplied together by each other, it becomes a positive number. So the whole thing becomes a positive number. So I believe this is right. You can check it yourself. I'm not going to check it here. Print np dot product A axis equals 0. So if you multiply by in the 0 axis direction, 1, 2, 3, 4, 5, 6, minus 5, 6, 5, minus 6, 7. Axis 0 direction, you will get 1, the first entry, 1 multiplied by 4 multiplied by 5, which is 20. Same with this 60, 126. 3 multiplied by 6 multiplied by 7 is 126. So you get that one. The next one, print np dot product of A axis equals 1. Along axis 1, you get 1 multiplied by 2 multiplied by 3. 6. 4 multiplied by minus 5 is minus 20. Minus 20 into 6, minus 120. And this row is 210. So you are getting 6 minus 120 minus 210. And this vector. Okay, that is fine. Those are the row operations. Operations we can apply on matrices. There can be many other defined functions. Depending on the application, we can use them accordingly. So that concludes that section. Okay. I feel a little bit tired today. I don't know why. Next is the subsection, numerical linear algebra. Okay. Mm, some topic is solving linear equation. A multiplied by x equals b. Okay. Can you remember this from your linear algebra knowledge? So let me say I have two linear equations. X1 plus 2x2 2 x2 x1 plus 2x2 equals 10. The next one is x1 plus minus x minus x2 equals 7. Okay. These are my two equations. Equation 1 equation 2 okay, that's fine. Now I have my two equations. I want to solve this for x1 and x2. So I have two equations, x1 plus 2x2 equals 10. x1 x1 minus x2, 2x1 minus x2. Oh, wait. It's not 2x1. x1 minus x2 equals 7. So I can rearrange the left side in the matrix form to obtain the matrix form. The first equation becomes the first row. Like coefficient of the first variable 1, coefficient of the second variable 2, coefficient of the first variable 1, coefficient of the second variable -1. So this is that x1 x2 equals 10. So okay, This we call the A, this is X, and this is B. Okay. Now this one we call the coefficient matrix. Okay. This is the variable vector. Okay. Now can we actually solve this? So let me say my x2 equals x1 minus 7. I substitute that one in the first equation, x1 plus 2x2. x1 minus 7 equals 10. I try to solve this. 3x1 equals 10 plus 7 multiplied by 2, 14, which is 3x1 equals 10, 20, 24. Then x1 equals 24 divided by 3, 8. You substitute that one here. x2 equals 8 minus 7, which is 1. So the x1, x2, the solution x1 star, x2 star equals 8, 1. x1 equals 8, x2 equals 1. So this has to be the solution. So we should, how do we do that? How do we solve these systems of linear equations using linear algebra knowledge? Actually, not linear algebra knowledge, using the NumPy module. So this is how it's done. So first we define the coefficient matrix. For this system, it is np.array. np.array 1, 2, 1, 2, 1, minus 1, 1, 1. So 1, 2, 1, minus 1. That's fine. This is the coefficient matrix. Okay. The B vector, it is also defined. Array, sorry, 10, 7. Here, not that the B vector is a column vector, so we have to define it as a column vector. 10 and 7. Okay. Okay. We run that. Let me check if I have defined them correctly. Print A, 1, 2, 1, minus 1, correct. And print B, 10, 7, column vector, correct. Next, we can use the we can use the linear algebra module in the NumPy module, and we can use the solve function in the linear algebra module. So, right, x, the solution vector equals np dot Linear algebra. Linear algebra. Dot solve. I want to solve this. A, comma B. So this is using the matrix inversion method. What does that mean? Now what I did here is not matrix inversion method. I just solved them manually. Uh, Matrix inversion is something like this. Like you have A x equals B. Uh, you multiply both sides. If given the inverse of A exists, if A inverse exists, we can write we multiply both sides by A inverse. A inverse A x equals A inverse B. So these two will cancel out and x will be equal to A inverse B. So using this method, um, so some programmers have developed an algorithm to find the inverse of the matrix. So you don't have to do that. So it has been saved in the linear algebra module. So you have to use this. When I teach linear algebra, I'll teach you how to code that part, how to code the inverse of the matrix. So, okay, print x. Eight one, which is this one, right? X star, x1 star, x2 star, 8 1. Correct. That's enough for now for the numerical linear algebra. We can go into detail when we do linear algebra lesson. The next one is solving polynomial equations. Okay, let me write a polynomial equation. P equals 2x cube plus, sorry, 2x cube minus 9x squared minus 9x squared plus 7x, oh, plus 7x plus 6. Yeah, this is my polynomial function. Now, what is a polynomial equation? This becomes a polynomial equation when this is equal to 0. Okay, this is a polynomial equation. Okay. So how do we find the roots of this equation? Can you tell me? How do we find the roots of this equation? So I know you can't tell me because you are watching a video. So there are certain methods for solving. You may remember in your A levels, there's this thing called factor theorem and remainder theorem. We have different methods to find the solution. So the roots or the solutions. So how do we do this using the NumPy module? First, we have to define the polynomial np.array. We, we define it using an array. So what are the coefficients or the entries of the array? They are the coefficients of the x values, like coefficients of the each x term, starting with the highest term. So it is starting with 2 now. 2, which is the coefficient of x cube, comma, next coefficient of x squared, that is -9. Next coefficient of x, which is 7. Next coefficient of x to the power 0, which is 6. Okay, now we have defined our polynomial function. Next, root values. Now, what are the root values? Root values mean, it means when this polynomial function is equal to 0, like this polynomial function, when it is equal to 0, when this is equal to 0, we can find the roots. That means the values of x that satisfies this equation. So np dot roots of the polynomial function p. Print root values. Okay, I have made a mistake. Here, it has to be roots, not root. 3 to -0.5. Is that correct? We can check. Now I have my polynomial function 2x cubed minus 9x squared plus 7x plus 6 equals 0. We know that this is a cubic equation. So 3 roots have to be there. 3 roots. So Python has given me 3 roots. 1, 2, 3. So that condition is satisfied. Next, we need to see if these values satisfy the equation here. Equation 1 here. So I can substitute the value 3 here in the equation 1. 2 into 3 cubed minus 9 into 3 squared plus 7 into 3 plus 6. 3 multiplied by 3 is 9. 9 multiplied by 3 is 81. 81 into 2. 2 into 81 minus 9 into 9 plus 21 plus 6. This is 162 minus 81 plus 21 plus 6. Where did I make a mistake? 3 multiplied by 3 is 9. 9 into 9, 81. 3 multiplied by 3 is 9. 9 multiplied by 3 is 21. 27 here. Sorry, my mistake. 27 into 2. It is 7 into 2 is 4. 54. Okay. 54. 4 plus 10, 11, 6, 7, 8. 81 minus 81, which is 0, which is correct. 3 is correct. You can check if it is satisfying 2 and if it is satisfying for negative 0.5. Check it. So that's fine. So now that we know how to get the roots. Okay. Next function is reconstructing. Print np dot poly root values. This function is for creating the polynomial, original polynomial. This we want to create the polynomial, this polynomial using this root values 3, 2, minus 5. So it should get, we should get 2 minus 9, 7, 6. But instead we are getting 1, negative 0.5, 3.53. What's the reason? Okay, the reason is now the polynomial this has created this 1 into x cubed minus 4.5 into x squared plus 3.5 x plus 3 equals 0. Now let me say this one too. I can 2 multiplied by 2. Right? Uh, I can multiply the left hand side by 2 and right hand side by 2. It will not it will not harm to the equality. So I get 2x cubed minus 9x squared plus 7x plus 6 equals 0, which is equal to 1, equation 1. So this one and this one are same. Correct. So that's correct.